Hey guys, today we're going to learn about evaluating functions. So at this point you should know what functions are. It's the first concept that we learned in this unit that we're talking about, or what we learned in what we learned before this. If you don't remember what that is, make sure you check out my function not a function video and the notes that go with it. I also linked this nuggetizer video here for you because I first of all, I think it's hilarious, and second of all, it really gives you a visual of what a function is. So in a function, we have an input and we have an output. Okay. Another word for that is domain and range. And so, and another word for that is also input is also your x value. It's also domain. Range is also your output and your y value. So all of these words, well, not all of these, all of these words on this side are your input. All of these words on this side are your output. And so when we have a function, we have we talk about how x does not repeat itself, because if it does repeat, then it's not a function. Okay, so we're gonna take this a little bit of a step further, and we're gonna remember what we did in about sixth grade-ish. You should have learned this, and it is using the table to find the rule and then the output, right? So this should look a little bit familiar to you. If it doesn't 100%, it's okay. We're going to go over it right now. So here my equation is y equals x, right? And so I use this equation as my rule. So my rule here is going to be x. My output or my result is going to be y. And then I always start with an input value of x, okay? So here, my x is 0, so my input is 0. If my input is 0, then my output is 0. Okay? Here, my input is 1, so I substitute my x with 1 because that's what it's saying, that x is 1 in this case. So my output is 1. Here, my x is 2, so that means my input is 2, and then my output has to be 2 because there's nothing else we do to it. Okay? That is what... that is the basic of this concept that you learned in sixth grade. That is called was part of substituting values, which is a skill you need. And in this case, we're substituting values into a linear equation. Another thing that you need to remember is simplifying expressions. And so we did that at the beginning of our solving equations unit with combining like terms and distributed property, and then we simplified those expressions. So if you don't remember how to do that, please go back to refer to that. The reason we need to know how to simplify expressions is because when we're looking at this second example, y equals 2x, here our rule is different. Our rule is no longer just x, our rule is 2x. And so they're giving us the input, which is 0, but we don't know what our output is here. So in order to find our output, we're going to take this value of 0 and we're going to substitute it into our x, and then our x is right here. So I just put parentheses there to tell me that that's where I'm going to substitute, or whenever I substitute a value, and then I simplify this expression. 2 times 0 is 0. So I'm going to add a text box here because I thought I had one and I don't. There we go. 2 times 0 is 0. Okay? Same thing here. Now I have my input as 1. So I'm going to substitute that 1 into my rule, which I got from my equation. So 2 times 1, and I'm going to simplify that expression. 2 times 1 is 2. So remember, whenever you see a variable and a number next to each other, so a coefficient with the variable, that operation is multiplication. That's why we're multiplying here. So here, 2 times 2. Where did I get the 2 from? From my x value here. So I simplify that expression, and 2 times 2 is 4. Okay? All right, so same thing here. Now we have 0, right? Now we have x minus 2. So here we're subtracting 2 from x. Our rule is x minus 2. I'm not going to type it down here. If you want to, you can. But I do have this set up in my boxes. So 0 is going to be substituted where I see my x, because that is my input value here. And 0 minus 2 is negative 2. So I'm going to add a text box. Negative 2. I'm going to make that bigger so it fits in there. All right. Same thing with 1. 1 is my input in this section of the table. So that means wherever I see x, I'm going to put a 1 as my input. So right there. 1 minus 2 is negative 1. So I'm going to write it here. That is my output. So whenever I input a 1 into this row or this equation, my output's going to be negative 1. So last one. So 2 minus 2 is 0. So that is my output when my input is x. Excuse me, when my input is 2 for this equation or this row. Okay, so go ahead and try this next one by yourself. I am going to go over y equals 4 in a moment, but put me on pause and try this y equals x plus 3. It's very similar to what we just did, and it's just review. Okay, so let's look at y equals 4. So I do not have an x value here, so that means that I do not have an input. So that means that it doesn't matter what my x value is. My rule is going to be 4, so my y value is going to be 4. So I'm just going to duplicate that. I'm going to hit Control D. And if you are in a Mac, that is Command D. And I'm just going to move it over. Or Apple. So whatever my y value, in this case, it's not going to matter because there is no x. Now we're going to get, when we get further into our linear equations, you're going to see y and what that looks like on a graph. But for now, just know that our y values here are 4. All right, go ahead and you can try this one, make up one, and see what row you get. I gave you the options of inputting 0, 1, and 2. You can really input whatever value of x you want. It just needs to you need to make sure that it is a, if you want to do it for a function, you need to make sure that x does not repeat itself. All right, so when we're talking about evaluating functions, what you want to look at is it's function notation. So when we're writing an equation, we write it as y equals 3x plus 5. When we're writing it in function notation, we write it as f of x equals 3x plus 5. Okay? So the way we read this f parentheses x is f of x. So I just put this here to remind you. So that's the only difference between these two. So here in this example, we have if f of x equals negative 2x minus 3 and g of x equals x squared plus 2x, find each value. So in this case, this function is named f, this function is named g. And so we just write f of x, g of x. Sometimes you'll see it h, and those are the most common letters. You might see a couple of other ones, but the most common letters they use to name these are f of x, g of x, or h of x. Okay, so we're going to look at what this looks like. So in this case, we have f of 3. So what this tells me is that I am going to have an input of 3 because 3 is taking the place of x where I would have the f of x. So I need to take this this function and I need to write it here first. So the first thing you want to do is write the function you're going to use because this is function f, this is function f. That tells me I'm going to use this here. So I'm going to type it in. So negative 2x minus 3. And you can write the f of x in front of it. That would be perfect also. It really will look like this. F of 3 equals 2x, or negative 2x, excuse me, minus 3. So this tells me that I'm going to solve this or simplify this when my input is 3. So we do the same thing that we just did for the table, but now we're using it for function notation. So I'm just going to scoot this over. Negative 2. I'm going to put a parentheses around where my x is, and I'm going to substitute the value of 3 minus 3. Okay? So that's my second step. I need to substitute my value of x that is given to me to use everywhere I see x. And in this case, we just have x next to that negative 2. And then our last step is to simplify. So negative 2 times 3 is negative 6 minus 3. And then negative 6 minus 3 is negative 9. So negative 9 is my final answer. I like to box my answers. You can do that, or you can circle them. It's up to you. I'm going to circle this time, but I usually like to box them. Okay? All right. So that's the first example. The second example is this B example. And so here, it's telling us G of 4B. So this is different than what the first example that we did. So if you want to pause me and you want to try doing D, which is very similar to A, you can go ahead and do that. G is also similar, but you're using a different function. But if you want to just watch it and then go back and review it, that's fine too. So here we have G4 of B. So that means that I need to write this function down because this is my function G. So I'm going to type this in. That little triangle without the base is just shift 6, and that gives you that little triangle without the base. And we use that whenever we can't write the squared. So this is an exponent of 2. So x squared plus 2x. So what it's telling me is that and I'm just actually going to put the first part of it too so you can see. So it's really G of 4B equals, okay? It's going to be a little bit overlapped to here, but it's okay. Actually, let me move it a little bit this way. All right, so now that we have our first step in, we wrote the function, we're going to substitute wherever we see x, we're going to substitute with what we have to do. And I always substitute with the parentheses around it. It makes stuff less confusing. So 4b squared plus 2 times 4b. And we simplify. So this first part is just 4b squared. Move it over. So I'm just going to rewrite it underneath. 4b squared. And then the second part is 2 times 4b. So we just multiply. 2 times 4b is 8b. And this is your answer right here. So I'm going to circle it or box it. That's my final answer. And that's it. That is this simplified. Okay? So that is how we do that. So for this one, for -3, you're doing the same thing, but you're using -3 instead. Okay? All right, I'm going to do one more with you, and I'm going to do this one because it has the -7 outside of it. So I want you to see how that works. So this function is f of 0, so I'm going to use my f of x function. I'm going to open a text box here. So what this is saying is I need to find out what my output is, or what my function is whenever, or my output really, whenever my equation is 2x minus 3 and my input is f of 0, or 0 minus 7. So the way that I do this is I'm first going to substitute. So 0. And then it's really a double parentheses because you're substituting the other value also. Actually, not really. Scratch that. It's just like that. And then -3. Sorry. So -2 times 0 is 0. And then 0 minus 7 minus 3. You simplify that and your answer is -10. So let me see that one more time because I don't want you to be confused. So that's your answer. So I substitute the 0 and then I just put the -7 next to it. And so negative 2, and then I just use order of operations to simplify this. So negative 2 times 0 is 0, and then I move from left to right. 0 minus 7 is negative 7. Negative 7 minus 3 is negative 10. And that's how we get this final answer. All right, so you can go ahead and try the rest of these questions and see how you do. If you have any questions, feel free to reach out to your teacher. I hope this helped you. You can rewind this as many times as you need and look at the examples to help you with your practice. All right, have a great day. See you next time.